Look at some of the properties of definite integrals. These are going to really help you as you're looking at the integrals, both with antiderivatives as well as when you're doing them with area. So let's take a look at some of these properties. I've got a nice list going on here. Let me see if I can shed some light on it, make it a little bit better. There we go. So notice number one asks us if the bounds are the same. If we go from 2 to 2, 4 to 4, negative 20 to negative 20, then the area would be 0. Very important there. Now, notice on number 2, if you have a number that's between the bounds, you can actually split your area to go from the beginning point to the middle, to the number that's in between them, plus go from that number that's in between to the end. You can split your areas up into 2 sections. Now, if you have bounds going from A to B and it equals some number, but you switch the bounds, then you automatically made the area negative. Think about it. You're putting the rectangles in from left to right, and now you switch them, and it means you're putting the rectangles in from right to left. Okay? So it changes the sign on the area. Now, if we look at number 4, if our bounds go from A to B and we switch them, we have to put a negative on the outside of the integral. Now, for number 5, if k is a constant, so you have a number being multiplied times the function, you can actually place that number outside of the integral. You can't do that if it's a variable, but you can if it's a number. And then number 6 is if you have two functions being added together, you can actually split them into two separate integrals. Just keep the sign between them the same. Now, number 7 and 8 are unique to even and odd functions. So number 7 tells us if it's an even function, so notice the area, let's say from here to here, okay, these areas are going to be the same because you have y-axis symmetry. You actually can just double the area from 0 to a. You can do one side, calculate one side's area, and then double it. Now, notice with the odd function, though, if you are going from negative a to a, because it has origin symmetry, you're going to get the same area below the x-axis and above. So you're actually going to get your area to be 0 there. Good properties for the definite integral. Let's see if we can use them here. We're being told that, I'm grabbing a highlighter here. We're being told that the area from 0 to 3 of f of x is 6. And that the area from 3 to 7 of f of x is negative 8. So what if we want the area from 3 to 0? Well, we switch the bounds there, right? So that's the negative of the area from 0 to 3, which in this case was negative 6, which was 6, so we end up getting negative 6 there. Okay, if we want to go from 0 to 7, well, notice we have the area from 0 to 3, and then from 3 to 7, so we can actually just add those areas from 0 to 3 and from 3 to 7. All right, now the area from 0 to 3 was 6, and the area from 3 to 7 was negative 8, so we get negative 2. Pretty simple, but we have to look at what we have and use those properties. Notice on number 3, on the third one, we want the area from 3 to 3. Remember, if the bounds are the same, very easy. The area is 0. Okay, our next one, we have a number in front of f of x. So I've got 3 times the area from 7 to 3. Now notice we changed the bounds there. So in order to change them back and use the value we have to flip them. That puts a negative in front. So the area now from 3 to 7 was -8. So I've got -3 times -8, which gives me 24. Okay, now we're doing the area from 3 to 7 of 2 times 3f of x. Well, let's split those up because we'll deal with 2 separately. And then I've got 3f of x dx. Okay, now the antiderivative of 2 we know is 2x. And we're using our bounds from 3 to 7. That 3 in front of the f of x, I'm going to pull in front. And so now I'm going to get, let's see, 2 times 7 would be 14 minus 2 times 3, which is 6, plus 3 times, and we know this integral equals -8. So I've got 8 plus -24, which is -16. Okay. Now, the next one, we're told to get the area from -3 to 3 if we know that f is an even function. So remember, if it's even, we actually can calculate this to do the area from 0 to 3 and then double it. So the area from 0 to 3 was 6, and we'll double it, which gives me 12. And then our last one here for this particular f of x, and we're going the area from -3 to 3. We know that the function is odd. That tells me origin symmetry. So I know this net area is going to be 0. All right, just a few more to look at here. Oh, I love this one. We've got a nice graph of our f of x. And we want to know what the value is for the area from 0 to 3. So remember, this is where you're going to use your area from 0 to 3. So this part up here looks like a quarter circle. And then I've got a rectangle, and then I've got a triangle. So you can actually divide that up into any shapes you want. I'm going to do the quarter circle, 1/4 pi times, it looks like my radius there is 2. And we square that. Remember, area of a circle, pi r squared, but we're doing a quarter circle. Then we're going to add this rectangle area, looks like a 1/2, which would be 1 times 2. And then I've got this triangle here, which has a base of 1 and a height of 1. So I've got 2 squared is 4. 1/4 times 4 gives me just pi there, plus 2 plus a half. So it looks like I have pi plus 5/2. Okay. Now, if we want the value from the area from 0 to 4, so now we're going to add in this little piece here, this little triangle. Notice these two triangles are actually going to cancel each other out. So it looks like we're going to be left with the quarter circle and the rectangle there. So the quarter circle again and the rectangle, that left me with pi plus 2. Okay, now look at the next one. We want the area from -3 to 3. Notice this has y-axis symmetry. So I know this is an even function. So I actually can calculate this. I'll just do the area from 0 to 3 and I'll double it. Well, friends, we've already done the area from 0 to 3, and that was pi plus 5/2. So we can just distribute that and get 2 pi plus 5. Okay. Look at the next one. It says if f of 0 equals 5, what is the value of capital F of 3, where capital F is the antiderivative of f of x? Okay. We have to use the fundamental theorem on this. Okay, I'm going to go from 0 to 3 of little f of x. Now I know what this is. I know we found this value, but play out with me here if we went fundamental theorem. We would do the antiderivative of little f, which is capital F. and we would use our bounds, right? Okay, now we know what this equals. We know this equals pi plus 5 halves. We know what to do here. We can plug in 3 and 0. Now, we were told f of 0 equals 5. So now we know what to put in for here. And now if I want to find capital F of 3, I just need to add 5 to both sides. So that's pi plus, now 5 would become 10 halves, so that's 15 halves. Ooh, that's a back door into finding a value for a capital F function. Let's do one more like that so we can feel a little bit more comfortable, okay? So notice on this one that we are going from -2 to 2. Now, I'm doing that because of the values they gave me. I'm choosing those. So I'm going from -2 to 2, little f of x dx, and I know the antiderivative of little f is capital F. Okay, now this, I didn't find any of this, but look at what we need. We're going from -2 to 2. That looks like it's going to be this area doubled. Well, remember, we actually found that area, didn't we? We had the quarter circle and the rectangle. We just need to double it. The quarter circle and the rectangle. So the quarter circle and the rectangle was pi plus 2, and we need to double it. Now, plug in your bounds. Capital F of 2 minus capital F of -2. And we were told that capital F of -2 was -2. So that becomes plus +2. We can subtract it from the other side so that I get that capital F of 2 should really be 2 pi plus 2. So I hope that helps. A little bit of fundamental theorem to finish up there. But please don't forget to leave me a comment if you have a question or something that you'd like me to explain again. As always, don't forget to hit like and subscribe. That way you get a notification when a new video is posted. Bye bye for now.